Okay, good morning. So I go to the next chapter, which is algebra, and algebra in your book starts with solving systems of equations. So let me first define for you what I mean by a system of equations. Of course, when you have an equation, you have an unknown that you are looking for a value for that unknown, so that making the equality in the equation right. Yes, for example, you say that I have 2x plus 5 equals to x minus 1. This is an equation. You have an equality and you have an unknown. You're supposed to find the value for an unknown, for the unknown, in a way that if you plot that unknown inside the equation, the left-hand side becomes equal to the right-hand side. And if you can find that value is called the solution of your equation. Okay, but how many variables are involved here? There's only one variable, so this is an equation in one unknown. But now if I want to consider an equation in more than one unknowns, then of course I have more, so I have a little bit of problem. So for example, if I ask you, is this an equation? Yes, that is also an equation because I have some unknowns and I have an inequality. But how many unknowns are there? There are two unknowns. Yes? The lesson has started, yes. Okay, x plus y equals 1 is an equation. But if I ask you to solve this equation, what do you think? Can I solve this equation? So let me just clean the first one. Let me write it here. X plus y equals to 1. And I told you that, do you remember this convention in algebra? When I use two different letters, it means that they can be different or they can be the same. But if I use the same letter, then the value for that letter should be the same all over the problem. So here, how many solutions do you think are there? It means that how many numbers for x and y that you can imagine, when I add them, it becomes 1, yes? Infinitely many. For example, one possible solution is to put x equals to 0 and y equals to 1. This is one solution. Don't consider it two solutions. When I have an equation with more than one variable, when I make an assignment for x and y, here in this case we have two variables, then this is considered one solution to this equation. Yes, not two solutions. Yes, don't think that one is for x, one is for y. Any pair that I consider here is one solution. So this is one solution of this equation. Why? Because if I replace x with 0, replace y with 1, the left-hand side becomes 0 plus 1, which is indeed equal to 1. That is correct. But for example, do you think that x equals to 2, y equals to 3 is a solution? No, because if I replace x with 2, replace y with 3, the left-hand side becomes 5, the right-hand side is 1, so that is not a solution. So this is one solution, this is not a solution, but I can imagine, as Oscar mentioned, infinitely many solutions, yes? For example, I can choose x equals to 1, and then y becomes 0. This is also a solution. Yes, or I can choose x equals to, I don't know, 1/2, y equals to 1/2. That is also a solution. Yes, because if I put x and y there, the left-hand side becomes equal to the right-hand side. So I have infinitely many solutions. Any pair of real numbers whose sum is equal to 1 will work for me as a solution. Yes? Is that understandable? Okay, so this is, I want to see, how many unknowns do you have here? You have two unknowns. But how many pieces of information is provided for you by this single equation? One piece of information. The piece of information, I have one equality. One equality means that I have one piece of information. I have two unknowns, one piece of information, Usually this is the way that you need to think. I have 2 degrees of freedom, x and y. You can call them degrees of freedom. I can choose whatever I like in principle for x and y. But I have 1 piece of information. 1 piece of information removes 1 degree of freedom for me, but 1 degree of freedom is left. So it means that I have infinitely many solutions. Okay? So you shouldn't expect to get 1 single answer for this equation. But if I give you 2 equations in 2 unknowns, okay? So x plus y equals to 1, and I simultaneously tell you that x minus 1 is supposed to be 3. Then I use these curly brackets to put them together. This is conventional in mathematics. This is the symbol that you have to use. This here, in this context, this means and. Okay, this curly bracket means and in this case. So here, if I ask you how many unknowns do you see in these equations, so there are 2 unknowns, x and y, and how many equations you see 2. So I have 2 unknowns. How many pieces of information I have? I have 2 pieces of information. Usually, 2 pieces of information is enough, usually, to find the unknowns. To find 2 unknowns. Yes? This is called a system of equations. Yes? And I want to teach you how to treat them systematically. We want to try to find a way to solve them in a systematic way. But first of all, we need to understand what is the meaning of solving this system. Solving this system means finding all pairs. Finding all, so let me write it down here. Here solve means finding all pairs x and y so that both equations are simultaneously satisfied. Yes? So this word is important. So you need to give me a number for x and a number for y so that both of them are simultaneously satisfied. Yes? This is the meaning of solving an equation, finding all pairs that satisfy these 2 equations simultaneously because of this word and. So I told you that these curly brackets here means logical and. Yes? Okay. For example, if I give you x equals to 1 as before, x equals to 1 and y equals to 0, is this a solution to this system? We can easily check. We put 1 and 0 instead of the x and y in the first equation, then this becomes 1 plus 0 is equal to 0. So this is true. Oh, sorry, equals to 1. This is true. And then I put these numbers here. This becomes 1 minus 0 equals to 3. This is false. So this means that no, these numbers are not, they don't form a solution for my system because they satisfy the first equation but not the second equation. So you see that if I want to start guessing, it's not a good way because I have to concentrate on both equations simultaneously. So I shouldn't work based on my guess. Might be the system is so simple that accidentally you can guess the solution. Even if you can guess one solution, there is no guarantee that you have found all of them because you have to find all of them to claim that you have solved the problem. So this means that I need to find a systematic way to solve this system. And that one is called substitution method. So the most general strategy to tackle any kind of system is called substitution method. Or method of elimination.
Process.
Yes? And what is the meaning of that? It means that you go to one of your equations in your system and decide about one of the variables, make it the subject of that particular equation, and solve it, and substitute it in the second equation. That is why it's called substitution method. So what do I mean? So let me just do it for this system. It's very, very simple task to do. You go to your system, choose one of your equations. Of course, it is better to choose the simpler one. But it doesn't matter. If you bother to do the calculations, it doesn't matter which one you choose at this stage. For example, let me choose the first one. Okay? I choose the first one. And then you choose one of the variables. Again, the one with smaller coefficients are better. The one with the smaller coefficient is better. For example, it doesn't matter here. So let me concentrate on y here. So you see, I have two choices. One choice, which equation I choose. The second choice, which variable I choose in that particular equation. So I have chosen the first equation, and I have chosen the second variable. So what I do, I forget about the second equation. I concentrate here, and make this the subject of my equation. Making this the subject means that I want to make that variable alone on the left-hand side. Okay, so then it becomes easy. I want to make y alone, so I keep y here. Then I move the other variable to the other side. I already have 1 on the right-hand side. I move x to the right, it becomes negative x. Yes? And then, when this part is done, you go to your second equation that you haven't touched so far and substitute this y with that y that you got here. So then what happens? This becomes x, negative sign. Instead of y, I put 1 minus x, but be careful. If you write like that, that is wrong. You have to put a pair of brackets around that, and it's equal to 3. And then what is happening? If I ask you, what is this that I get? You say that this is an equation, but how many unknowns are involved? Just 1. And we already know how to solve that one. So it means that you need to take your time to solve this one as you learned, I don't know, even in grade school, yes? So what can I do? I multiply this negative sign in. So this becomes x minus 1 plus x equals to 3. X plus x is 2x. I move minus 1 to the other side. It becomes positive 1 and 3, 4. And then I divide by 2 to make x alone. X equals to 2. Yes? And when I found x equals to 2, I go and put it back here to find my y. Of course, you can put it here. You can put it here. I myself prefer to put it in this way because that is easier. Yes? But it doesn't matter. So here, then it means that I put it here, then it means that y is equal to 1 minus 2. And then this means that y is equal to negative 1. So what you need to provide as the answer is x equals to 2 and y equals to minus 1. This is what you have to provide as the answer for me. And then if I ask you how many solutions I got for this system, how many solutions I got? 1. So that pair, x equals to 2, y equals to minus 1, shouldn't be considered as 2 solutions. It is considered 1 solution for the whole system. What does it mean? It means that if I replace x and y with those values, not only the first equation is satisfied, but also the second one is satisfied. We can check in our head. X is 2, y is minus 1. I put it here. 2 plus minus 1 becomes 1. That is true. I put x equals to 2 here. Minus 1. 2 minus 1 becomes 3. 3 is equal to 3. That's also true. So you see that I found a pair of x and y so that it satisfies both equations in my system simultaneously. Is that clear? So I think because you know that in your lesson you don't have very complicated systems, that is why we have also another method to calculate, to find the answer, and that's called the addition method. I will also teach you that. But this is the main strategy. Remember this trick. Method of substitution method or method of elimination. Why it's called method of elimination? Because you see I eliminated y. The equation that I have here no longer depends on y. So I have eliminated y from the first equation. So that's why sometimes people call it method of elimination. And then I substitute this expression for y, so we can say that also called substitution method. So this is a very important strategy in mind. So if you have that strategy, you can solve harder questions. But is this understandable for you? Yes or no? Yes. Okay, so let us make it a little bit more involved. I told you that at the level of your lesson, you only face with these type of equations. You don't have powers on x and y. You don't have cross terms of x times y or something. You have only 2 equations, and then you will also learn 3 equations with 3 unknowns. Okay? But the idea is more or less the same. Okay. Before going further, I want you to find a connection between algebra and geometry. This is algebraic way to do this, and I believe that this is superior because algebra is precise and exact and you find exact values. But can you describe me, if I want to do it using graphical tools only, assume that you have a graphical tool on your calculator or whatever, and you want to solve this system. Of course, GeoGebra is advanced application. You can ask solve, I will show you, and then put the system there, and GeoGebra will give you the answer. But assume that you do not have that option available, you only have graphical tool in GeoGebra. Can you tell me how using graphical tools there I can find this answer to a system of equations? Not every system, but just this system. Because this, I will not probably give you these kinds of questions in the exam, but it is extremely, I'm emphasizing, it's extremely important to understand the graphical method, why the graphical method will work, as you will describe. So any ideas what to do if I want only have graphical tool in my hand? Yes?
Maybe try to write both of the equations so that it becomes equation of a line.
Yes?
So we make y alone on the left side and other things on the right.
Okay, and then?
And then place them in a coordinate system.
Okay, so you ask GeoGebra to draw them. That is what you say. Using the graphical tools in GeoGebra or whatever you're using, you ask your program to draw them. But this is not finished. Okay, assume that now you have drawn this one and you have drawn this one in one coordinate system. Then what? Yes?
The intersection point.
Yes. Then you try to ask your application to find the intersection point of these two lines. That point has one x coordinate and one y coordinate. The x coordinate of that point will be this number. The y coordinate of that point will be the other number. Okay? So before going any further, let us demonstrate it using GeoGebra. Okay? Okay. So here we go to GeoGebra. I think GeoGebra can calculate those. So do you remember what was it? It was x minus y equals to 1. So that's good. So you really don't need to do that step that you mentioned. So GeoGebra automatically can draw that line. Yes?
It was x plus.
Was it x plus y?
Yes.
Yes, thank you. Thank you for mentioning that. So let me just do that. So it was x plus 1. Yes, but what actually Ali mentioned was correct. But GeoGebra is a little bit more advanced. You really don't need to make y alone, at least for these simple cases. Okay, so let us just draw that. That is your law. What was the second one, Sergey? Do you remember?
X minus y was 3.
X minus y was 3, yes? And that is the other. And of course, I can use this tool, but of course, this is very clear here. I go here and find the intersection point between these two lines. And that is my point A. And now go here, you see that this is on the GeoGebra. So the point A of intersection between these two has x equals to 2 and y equals to minus 1. And do you remember exactly that was the answer that I got using this algebraic point of view? Okay. But of course, algebraic point of view, algebraic method is superior to this geometric way because of course here, if these numbers are different, then it might not be on exactly one of those grids. Then the GeoGebra using graphical tool will provide you approximate values up to the precision level for the GeoGebra. But in algebraic method, I can find exact values. But this idea to imagine this geometrically is super important. So you really need to understand this problem both from algebraic and geometric point of views. Is that clear? Yes or no? Okay. But I think you can also go to CAS view in GeoGebra. I think there is a, that is also good to learn. If I go to CAS view, now here I think you can start using solve, and then you see that there is called solve list of equations, list of variables. So if I press that one, and I think in GeoGebra list starts with curly brackets. So for the list of equations, I have x plus y equals to 1, comma. I am separating the elements of my list by a comma, and then I have x minus y equals to 3. This is the list of my equations, and then I go to the next one, and then here I have to write the list of my variables. So I again open curly brackets. I think GeoGebra always use curly brackets to name lists, and then I have my variables, x and y. So let me make it a little bit bigger that you can see, oh, everything is gone. I don't know why this version is doing, okay, it's coming back. Okay, so you see I wrote solve, and I put my equations one after the other in a pair of curly brackets, and then a comma, a curly brackets introducing the variables, x and y. And GeoGebra solves this system and finds x equals to 2 and y equals to minus 1. So with this software, you can solve more complicated equations. So you need to know how to implement it. So that is one point, but the important point for me here, for you to understand this connection. Okay? So let me ask you one question to test your understanding. Okay, I want to ask your opinion about this. Okay, so let me write this system for you now. Instead of doing it like that, I write it like this. For example, 2x plus 3y equals to 2. And then I give you 4x plus 6y equals to 1. Okay, and I want you to solve this system. Let us see what happens. Okay, try to help me to solve this problem using the substitution method to see what is going on. I told you that in the substitution method, you need to choose one of the equations. Which one we prefer? The one with the smaller numbers. So I myself prefer to do this one. It's up to you, of course, it doesn't matter at the end. So let me choose the first equation. And let me concentrate on one of the variables. So if you don't mind, let me concentrate on this variable this time. Let me make x alone. It doesn't matter, you can make y alone. So how should I do that? I write 2x here, and I move 3y to the right, So it becomes 2 minus 3y's. But my goal is to make x alone, so I have to divide everything by 2. So x becomes equal. 2 divided by 2 is 1. 3 over 2, let me keep it as fraction. This is what I get. I have made x alone. Then I have to go to the other equation that I haven't used so far and substitute this expression for x variable. Yes? So what will happen? This means that I will take it and put it in the second equation instead of x. So this becomes 4. Instead of x, I put this 1 minus 3 over 2y. And then I have plus 6y is equal to 1. And then I don't have any problems here because I have one equation and one variable. So I multiply 4 in, 4 times 1 is 4. I multiply 4 here, it becomes 12 over 2, which is minus 6y. And then I have a positive 6y here, and then the problem is appearing here. This one and that one are now gone, instead of making it alone. Then I get something very strange, that 4 is equal to 1. Okay? So this doesn't mean, so some people say that this is wrong. No. I have a right to ask you, I gave you a system, and I am waiting for you to give me a solution, if possible. Yes? But then, when I wanted to solve it exactly using the same strategy, I got something strange. So that is up to you to interpret this contradictory result. And what is the interpretation? So at this point, what should I say for this system?
That there is no logical solution.
So why did you add the adjective logical? There are no solutions.
Still no solution.
There are no solutions for this system.
Unless you
Why? Because if you assume there is a solution, you have to agree that 4 is equal to 1. Because if you assume that there is a solution, because when you are solving the system, it means that you think there is a solution and you are looking for it. But now, if you assume that there is a solution, you have to admit that 4 is equal to 1. But this is not possible, so it means that there are no solutions. So here, you stop. You shouldn't say wrong. What you need to provide for me as the answer, you would say that answer, there are no solutions. Or there is no solution, it's probably both, yes. There is no solution for this system. Okay? Now I want to test your understanding from going the algebraic picture to geometric picture. What do you predict if I do the same thing with Geogebra, but instead of asking Geogebra to draw these two lines, if I draw these two lines, what do you think will happen? Because you know, from algebra you know there is no solution. So what is the interpretation of this when I go to geometry? Yes?
The two lines won't cross.
Won't cross. It means that the two lines are
Parallel.
parallel.
Right.
Yes? Could you check that these lines without graphical tool? Yes, you are right. You will draw them and you will see that they are parallel. But even if I do Geogebra, it seems parallel to me. There is no 100% guarantee that the lines that I see parallel, they are indeed parallel. Because they might deviate from being parallel so small that I cannot detect the difference, yes? But algebraically, I am 100% sure, from algebra point of view, that these two lines have to be parallel. Why? Yes?
If we were to solve both equations for y to get the k form,
K value.
yeah, then we can get the k value and see that
The K values are exactly the same, because you remember in the previous chapter we learned that if the K values are exactly the same, then they are parallel. So that is exactly what you mentioned. So here I need to put it in the K form. So can you do it in your head? So I would say 3y is equal to 2 minus 2x. Then I divide everything by 3. So y becomes, if you don't mind, let me write this one first. 2/3 of x plus 2/3. This is the k form of the equation of this line. And if I want to do the same thing here, I have to move 4x to the right. So 6y is equal to minus 4x plus 1. And I divide everything by 6. Y becomes minus 4 divided by 6 has a simpler name, which is minus 2/3. X plus 1 over 6. So you see that if I ask you what is the k value of this line, if you interpret this equation as a line, the k value is minus 2/3, and the k value for this equation is also minus 2/3. And then they are the same. So they have to be parallel. Yes? Is that clear? Okay. We can also test it using GeoGebra later. But can you tell me what are different scenarios that you can expect for a system of two equations of this type? So let me write a system of equations for you. This is a very important property. So if I give you an equation of this form, ax plus by equals to a constant c, I don't know, another number, usually we call it a prime. Are you comfortable with using this symbol? A prime is a different letter, yes? I'm just writing it a prime. X plus b prime y is equal to c prime. A, b, c are given. A prime, b prime, c prime are given. So for example, if I ask you, can you tell me in this equation, if you compare this equation with what I have written here, 2 is playing the role of A, 3 is playing the role of B, and 2 is playing the role of C. In the second equation, this is A prime, this is B prime, and this is C prime. Yes? That's it. Now I want you to tell me, what are different scenarios going on for such a system? In other words, do you think that this system can have two distinct solutions? Can this system have infinitely many solutions? Can this system have one single solution? This is important. You see, I want you to fully appreciate the different pictures. Geometric picture, algebraic picture. If I ask you, is it possible that I have two solutions for this system? It is hard to answer this question algebraically. But geometrically, it is very, very simple if you understand what is going on. Now answer me. Is it possible that you write an equation like that and then start solving it, you get two pairs for x and y? Is it possible? Algebraically, it is not easy to answer this question immediately. You have to do a lot of algebra. But geometrically, it is very clear. The answer is yes or no. Only two, exactly two solutions. Is it possible? Why no, Sergey?
Because straight lines, they can have two intersection points.
They cannot have exactly two intersection points. So if I have two lines on the plane, for example, this is one line, this is another line, either these two lines are parallel, there are no intersection, or they cross one another at exactly one point, or they are exactly the same. They lie on top of each other. Yes? So now let me ask you the question. What are the different possibilities for the number of solutions of any kind of systems of this form? How many possibilities are there? I can have exactly one solution. So exactly one. No solutions. And suddenly infinitely many solutions. Yes? When it happens, when the lines are lying on top of each other. Yes? So if you just randomly choose A, B, C, A prime, B prime, C prime, you introduce infinitely many equations. But the point is that there are three scenarios going on. Either your system does not have any solutions at all, or it has exactly one solution, or suddenly it has infinitely many solutions. You cannot write a system of exactly this form with exactly 2 solutions, with exactly 3 solutions. Is that understandable? So I want you to understand, we were able to answer this very deep question not using algebra, but using geometry. Yes? So these kind of arguments, geometry is very powerful. You imagine them and then, but of course, geometry doesn't give you exact value for the solution if I want to find the exact value. Then I have to do algebra. If I practically want to find the exact value for the answer. This is very, very important. I want you to understand that. Is it understandable for you? Yes or no? Yes? Okay. Okay, now can you tell me a system based on geometrical perspective? Please give me a system that you are sure that has infinitely many solutions. I take your example and start doing algebra with your example, and I want to confirm that yes, this system has infinitely many solutions. Can you give me a system of that type? So I want you to write for me 2 equations. Do you remember? I wrote 2 systems for you. I wrote this one and I solved that. I had one unique solution for it. I gave another system and I solved that. I didn't get any solutions for that. Now I want you to do this favor for me, to find an equation, a system, and tell me that if you solve it, Babak, you will get infinitely many solutions. Yes, Sergey?
X plus y is equal to 1 and 2x plus 2y is equal to 2.
Exactly. Thank you very much. Okay? So that's exactly. If we solve this system, then this system will have infinitely many solutions. How Sergey was able to predict this? Because he thought about it in this way, might be, that he wants 2 equations but representing the same line. Because we learned that if the system is supposed to have infinitely many solutions, the equations should lie on top of each other. If 2 lines are lying on the same line, it means that how many intersection points we have. If I have this line and that line, but these 2 lines are lying on top of each other, each point lies on both of them. So I can say that I have infinitely many intersection points. And do you agree that this equation and that equation, are these 2 equations identical? No, be careful, the word identical. Are these 2 equations equivalent? Yes. Be careful about these differences. So if I ask GeoGebra to draw this, the graph of this, it will be a line. If I ask GeoGebra to draw this, it would be exactly the same line. Because whatever satisfies here will satisfy here and vice versa. Okay, but let us do it algebraically. So you were able to predict this system, but let us assume that I want to use the substitution method to solve this one. So let us do that, let us see what happens. Can you tell me now, can you predict what will happen algebraically? So you were able to give me the correct system, but can you predict, before I do the calculation, what will happen from algebraic point of view that will give rise to infinitely many solutions? Of course, if I do the calculation, it becomes evident. But before going to that step, you can look here. A contradiction happens here. What do you predict from algebra point of view will happen for that system? Yes?
We will not be able to solve this system.
Okay, we were not able to solve the system here either.
But that will not contradict.
So what will happen? It does not contradict what will happen. Yes, Simon?
Maybe it will be the same variable on both sides, just the variable. For example, x is equal to x.
Okay, so what do you mean actually? It means that you get a statement which is always true, independent of my choice. Yes, you are right. This will happen. Let us see if it really happened or not. If I want to use the elimination method, which equation do you prefer to choose, the simpler one? Which variable you want to choose, it doesn't matter, so let me choose this one. and then I want to make y alone. So what happens? Y becomes 1 minus x, and then I go to the other equation and I substitute this for y. So this becomes 2x plus 2. Instead of y, I put y minus 1 minus x equals to 2, and then I start solving this. I multiply 2 in, and then you see these 2x and 2x are gone, and what is left is no longer contradictory, but identity, yes? 2 is always equal to 2. So what does it mean? It means that it doesn't matter what value I choose for x. It will give me 2 equals to 2. So it means that's an identity, yes? So it means that when I do this, so feel the difference. You see, here, the variable that I was looking was gone, but I get a contradiction. The interpretation is no solutions. Here, the same thing is happening. The variable is gone, but a true statement is left, no contradiction. The interpretation of this is I have infinitely many solutions. Why? I want you to understand why this statement is the interpretation. Because when whatever you choose for x, it doesn't matter because x is gone and what is left is true. So you can choose whatever you like for x. You will get the same true statement. And when you get something for x, anything you like, you put it back here, you get something for y. So it means that I have infinitely many pairs that can satisfy this system simultaneously. So is that understandable? So be careful about this point. Okay, I want to a little bit talk about the algebraic geometric point of view. I want you to understand what is going on. For example, later, of course not in your course, but if you just join these Olympiad classes, one of the topics that we want to teach in algebra part is solving different kinds of systems. They are happening in mathematics Olympiad questions a lot. So, but before that, I want to ask your opinion. Assume that you don't know algebra, but I give you this system. Okay? So first of all, do you agree that this is a system of equations, but not a standard one? The standard ones for you doesn't include any powers for x and y. But here, this curly brackets means and then I have two equations, but this is not a standard because I have some powers of 2 up there. Yes? Okay. This is one of those systems that you really can solve it algebraically. Yes? How should I solve that?
We know that y and x is equal,
So that the method of substitution, yes, again work. So this is why I'm telling you, the method of substitution is the general technique that we have in our hand to solve systems of equations. So here, I have to choose, I told you that method of substitution tells you choose one of the equations. Of course, which one do you want to choose? If you choose this one, it doesn't mean it is wrong, but you are making life much harder for yourself. But if I choose this one, it is already done. And then I have already y alone. So that part I really don't need to do. What I need to do, I need to go to the equation that I haven't used so far. Yes? And then instead of that, instead of y, I eliminate y in favor of x. So what should I do? I write x squared plus, tell me, instead of y, what should I write?
X.
X again, so it becomes x squared. And then it becomes what? 4. This is a very important from conceptual point of view. Please listen. So then, can you find x for me? Later, we will learn how to solve quadratic equations in general, but this is a very simple one. You really don't need any kind of lesson to solve it. X squared plus x squared has a better name. What is the name? 2x squared is equal to 4. And then I want to make x alone, so x squared becomes 2. But now can you tell me what is x?
Square root of 2.
The square root of 2 is not complete. Plus or minus the square root of 2. So it becomes minus the square root of 2, a square root of 2. What is the logical connective between them, and or? Or, because x cannot be minus the square root of 2 and the square root of 2 at the same time. So I have two answers for x. But I want you to tell me in the exam, I want to write my answer for that system. What do you write for me? You cannot stop here, do you agree? It is not finished, because solving a system doesn't mean finding x. Don't get confused. Because you have two answers, don't think I am done. No. You need to find a value for x and a value for y. That collection becomes one solution. Yes?
Well, x is equal to y, so...
Yes, so what should I write? I should write x equals to...
plus minus square root of...
No, I want to write and, or, and every details.
Oh,
Okay, so what should I write? X equals to square root of 2.
yes.
Okay. Y equals to what?
Square root of 2.
So what is the connection?
But they're equal.
And
And or.
And or.
And. This is and.
Oh,
Or another scenario. What you have to write in this way, this is the way that you have to present the answer. So let me ask, is that understandable? So you see there are two answers for x, but I want to find an answer for system. For a system, I need to give you x and y. That package as a whole becomes one solution. Now if I ask you, how many solutions are there for this system? What is your answer? How many solutions are there? Two solutions. One solution is this pair or this pair. And one solution, the second solution. Is that clear? Yes or no?
yes.
Okay. So let me go to GeoGebra to see how this system looks like in the GeoGebra. Okay. I don't know if the GeoGebra can do that, but I hope it can. Okay, so here let me draw the graph using graphical tool. Of course, I will use that one is just typing, but there is no concept behind that. Let us understand it from graphical point of view. One of them, you know what to do. Y equals to x. What do you expect? If I put y equals to x in GeoGebra, what do you expect? What shape do you expect to get? Y equals to x.
It's a diagonal.
Now, first of all, is it a curve or a straight line?
Straight
It's a straight line, yes? It's a k form. What is the k value for y equals to x? 1. What is the m value? 0. Yes? So let us just do that. That is very simple. Y equals to x, and that is what you predict, hopefully. Is that understandable that it should be here? Because when I put y is equal to x, every point on this line has this property that its x coordinate is equal to its y coordinate. Y is equal to x. But might be the other one is not that easy for you to guess. We will probably learn that later. So let me write x to the power of, I don't know if GeoGebra, because that is not a function, that's an implicit function. Y to the power of 2, it is equal to 4. And that's a circle. Yes, circle whose center is the origin and its radius is 2 units. And then I want to find the intersection points. But how many intersection points are there? 2, yes? Let us just do that. Intersection between the circle and that one. These are points A and B. So these points A and B show you that there are two answers, there are two solutions for my system, not just one. And then if you go here and read the coordinates, I hope that you see that 1.414 is approximately square root of 2. So this is why I'm saying that algebraic method is superior, yes, because we were able to get exact value. But at least that is better than nothing. So you see that I have two pairs of solutions. Sorry, yeah, I have one pair of solutions. So this x is minus the square root of 2, minus the square root of 2 for y, and the other one positive square root of 2, positive square root of 2. That 1.414 is approximately square root of 2. Is that understandable? So this is important that from graphical point of view, you can solve the problems. And then let us see that if GeoGebra can also calculate this. So I go here to GeoGebra and I want to change these equations. So it becomes y equals to x. And then the other equation, comma, x to the power of 2 plus y to the power of 2 equals to 4. And then let us see how it goes. Yes, so GeoGebra also is capable of giving you exact values. So it was able to give you this pair and that pair for different solutions. Yes? So, but you see that algebraic method is superior if you want to find exact values. But from geometrical point of view, the number of qualitative arguments regarding your system, geometry is faster. Yes? So I want you to understand this is extremely important. To understand when you are solving a system algebraically, what it means geometrically. I hope that these examples can provide you some insight. Yes? Let me also ask you this question. Another problem with geometry, can you tell me what is another problem? A very big problem with geometry rather than algebra. My question probably is not very clear, but I mean that except for exact values, that's a little bit of weakness of geometrical approach. What is another very, very important weakness of geometrical approach? Let us talk a little bit deeper in this case. How many variables were involved in this problem? How many variables were involved? 2, x and y. How many axes do I have in my coordinate system? 2, x-axis and y-axis. Now, can you imagine a system containing 3 unknowns?
Yes.
Yes? So instead of writing x plus y equals to 1, I can write x plus y plus z equals to 1. Yes? And I can write another equation with x, y, and z, another equation with x and y and z. Then if I want to use geometrical approach, how many axes do I need?
3.
I need 3. Okay, so far so good. I have one axis here, the other axis here, another axis there. So that's good. But then you immediately, something happens, yes? I can immediately imagine how many equations? 4 equations with 4 unknowns. I can imagine 5 equations with 5 unknowns. Then I will not be able to draw axes perpendicular to each other all the time because we are living apparently in 3 dimensions of space. So it means that that is also a very serious problem for geometrical approach. Yes, Tim? Can you speak louder, please?
What?
Speak louder.
May not be systems of equations, but is there any way to calculate run calculations in a 4-dimensional space?
Even if you can find, then you need to know that because you know that in principle we can have millions of equations with millions of unknowns. So for example, if you have an electronic circuit and then you just want to find the electric current in each branch, and if the branch is complicated, so assume that you can have hundreds of equations with 100 unknowns. So I mean that there is a limitation. I don't want to emphasize on that if we can solve it for 4 dimensions or not. That's a different problem. But I just want you to understand, if you want to solve it for 4 axis, then you can ask what about 5, what about 6, what about 7. So it means that, and drawing the graph of these things becomes harder and harder. And by the way, I think the algorithm behind this application is just using a geometrical method to find those points and connect them somehow so that you are thinking that the graph is done. Yes? But I want you to understand that the picture, the connection between geometrical picture and algebraic picture is actually very important to realize. That is very important to understand. And I want you to know the weaknesses and the advantages actually of the geometrical approach compared to algebraic approach. Any questions? Okay. I was just thinking that, for example, let me give you another system of this type. X to the power of 3 plus y to the power of 3 equals to, say, 1. And then let me write x plus y equals to 1. Okay? I don't know. I want you to understand, if I ask you to solve this system algebraically, it might be hard. Even I don't know if I can solve it myself. Okay? Why is that? But I want you to understand something. If you give me this and I want to start solving this algebraically, the first way that I think is definitely elimination or substitution. But of course, it might not possible to work it out. Why is that? Why the problem is there? For example, if I want to solve this system using algebraic method. So what I am supposed to do, any system I told you, you choose one of the equations which is probably simpler. Which one is simpler? Definitely the other one. Yes? And then what I get is, what do I get? I get one of the variables in favor of the other one. Yes? By the way, this is something that you can guess at least one solution. Can you guess before solving anything? Can you guess something? I just want you to tell that even if you guess, that is better than nothing, but that is not the complete solution. Can you guess a solution for the whole system here? At least one? Yes?
1 and 0.
1 and 0. And immediately you get another solution.
0 and 1.
0 and 1. Because this is completely symmetric. You see, when you say, by the way, that is also, there are important things that you are learning now. So Google mentioned this solution, but you immediately see that is also another solution. So far, should I write both of them or one of them? Both of them. Be careful. This is one solution. This is another solution. Why they are considered two different solutions? Because this is x equals to y, x equals to 1, y equals to 0. This is this point. This is x equals to 0, y is equal to 1. This is another point. So don't consider them as one solution. There are two solutions for the time being. But can I claim at this moment, can I claim that I solved the problem? So forget about this. I got two solutions. That's it?
No,
Can I claim this right now? Why not?
because we haven't tried to get.
Because there might be
There might be.
other solutions as well. So even though I got a pair of solutions, still I cannot claim that I am done. Yes? Because I might have another solution. But now, if I want to confirm this algebraically, what should I do? I go and take one equation and I put it back here. Then I will be in real trouble. Not real trouble. You can solve it in the future. But the point is that, what is the equation? This is equation of third degrees. Then I have to do an equation of third degrees, but I can immediately see that the third degree will be cancelled out, so that's not a big problem. So it will be of second degree, and for the second degree we will learn how to solve it. But now, assume that this is hard for you and you cannot solve it. and you were able to guess these two solutions. Now you can use graphical tool to see that how many solutions are there. If there are two solutions, then it means that yes, I found them and the system is solved. So I want you to understand this interplay between geometry and algebra. And that would be my last demonstration, okay? And then we will be, I will let you to work on yourself, okay? So let me just do this one once more. Okay, so now even for me it was not clear, it is not still clear what would be the graph of x to the third plus y to the third equals to 1. But hopefully GeoGebra will be able to draw it for me. But let me just draw the first one. X plus y was equal to 1. That is my line. And the other one, let us see. And let me change the color of this one. I don't know why GeoGebra doesn't change the color automatically, but let me go to setting and then change the color to red, for example. Yes. Okay, and then let us go back here. X to the power of 3 plus y to the power of 3 equals to 1. Okay, so that is a fancy graph here, yes? And actually, I hope that, now can I claim, if this is reasonably precise, can I claim I solved the system by guessing? If it is reasonably precise, I would say yes. Because what do you see? How many intersection points there are?
2.
There are 2. Yes, and exactly as we predicted by chance, yes? Or actually not a chance, just educated guess, yes? That was 0 and 1, x0, y1, and that one is 1 and 0. Okay? But if you want, of course, if you want to make it a little bit sure, you can zoom in to see if something strange is going on. Apparently not. But still, can I be sure that I solved the problem? If I want to have 100% certainty, I would say no. Because might be something strange will go on. Unless still you have other methods that will be calculus, and you will start learning them in Math 3C to understand the behavior of the graphs. Then you will see that, of course, for the straight line, there is no surprises there for me. I know that the straight line will continue forever. But might be this unknown graph have some strange properties that for some reason it starts oscillating up and down. If it is oscillating up and down, might be I will have more intersections, yes? But as far as I see, and if this I can trust it, we can claim at this moment that we were able to solve the system by guess. Because we were able to see that there are no other solutions, and we were able to guess the solutions. Is that understandable? So, next lesson, I will give you systems and ask you to solve them. But I really want you to understand the connection between geometrical and algebraic approach when it comes to systems. Okay? Okay, we stop here, I think. Okay, I stop here and then I will try to update the Google Classroom. So don't waste your time. You have nearly 40 minutes. You can have a rest for 5 minutes or so and come back to work. By the way, this part is not included in the coming exam. Exam is on the other part, the first chapter, and that one small piece on chapter 5. Yes? In analytic geometry.